Hello students, today's video is titled Simplifying Algebraic Expressions. So we have a few things to talk about before we get into some examples. The first thing I'm going to talk about is this statement right here. I'm going to introduce some new language to you today. So there's a word in math called a term. Here's the definition. A term is a part of an expression that can be added or subtracted from the rest of the expression. You've really been dealing with terms your whole math life, but you may not have called it a term. So let me explain. So back in, elementary school, you might have had a problem that looked like this. 10 plus 3 minus 7. Because each of these numbers is separated by either an addition or subtraction sign, that automatically makes each one of them a term. So 10 is a term, 3 is a term, and 7 is a term. All because they're connected with addition or subtraction. Now, when you add them left to right or subtract, use order of operations, 10 plus 3, well, that would become 7. 10 plus 3 would become 13. And then 13 minus 7 would become 6. So you go from having 3 terms to 2 terms to your final answer, which is 1 term. So that's all a term means. And you can have it with letters too. Like if I have x plus y, x and y are separated by a plus sign. Each one is a term. So this is 2 terms. And that's all there is to that. Okay, let's look at the next little bullet here. In the expression 7x plus 8y plus 5z, there are 3 terms. Do we agree with that? The terms are 7x, 8y, and 5z. I think I agree with that. I think 7x would be a term. Then comes the plus sign, followed by 8y, which is a term, followed by 5z, which is a 3rd term. So I would have to agree. Good. Okay, next bullet. Here's new language. A coefficient, let me circle that word. A coefficient is the number in front of a variable. And a variable is a letter. So a coefficient is the number in front of a letter. In the term 4x, 4 is the coefficient. Absolutely. I can give you another one here. 5y. The coefficient is 5. Negative 3t. The coefficient is negative 3. Okay? And our last bullet, like terms can be combined to simplify an algebraic expression. To be like, terms must have the same variable, and that variable must have the same exponent. Let me give you an example of that. So if you wanted to combine 6x with 2x, you would totally be allowed to do it. These are called like terms. So you have 2 terms, 1, 2, and they're like for 2 reasons. 1, they both have an x. The letter is a match. Secondly, the exponent on that letter is a match. This is like raised to the 1st power, and so is this. So 6x plus 2x equals, all you do, add the coefficients. 6 plus 2 is 8, and you bring the x along. So if you have 6 of these and 2 of these, now you have 8 of these, 8 x's. That is called combining like terms. And if you don't believe me, we can test it. Let me grab a different color here. If we would take x, which is just holding the place for a number right now, say we let x be 5. So let's let x be 5. Well, if we plug a 5 here and we put a 5 here, we know that 6x, when they're butted up against each other, means multiply. So 6 times 5 and 2 times 5. Okay, well, 6 times 5 is 30, and 2 times 5 is 10, and 30 plus 10 would give me 40. Now, if I come over here to the 8x, and I let the x be 5, 8 times 5, 40. So you're going to get the same answer, whether you leave it as 2 terms or combine it into 1. Great. Okay, last but not least, we have 4 examples of combining like terms. We'll start with an easy one. 2x plus 3x. This is almost just like the one we just did. We may combine these 2 terms since they match on the letter x, which means we just take the coefficients, 2 plus 3, and that's going to be 5x. So easy. Let's try another one. Now we have 3 terms, 8x minus 2x plus 5x. These are all like, they match. But if we run order of operations, we know that subtraction and addition are on an equal playing field, so we must work left to right. So let's start on the left side. 8x minus 2x is going to be 6x, since 8 minus 2 is 6. Bring down 5x. And now we'll add those together, and that will be 11x, final answer. Pretty simple once you get rolling. Okay, and the last 2, we've got 3g plus 7g minus g. One thing I want to point out, when a term does not have a coefficient, like this term has a 3 for its coefficient, a 7, this has nothing. You are to assume it's 1g. Okay, there's like an imaginary 1 there. So we have 3g plus 7g minus 1g. Again, addition and subtraction, we will work left to right. 3g plus 7g, 10g minus 1g, and 10g minus 1g will give us 9g, final answer. Okay, and the last one for this video, a little bit longer. Let's count how many terms we have. We have 1, 2, 3, 4, 5, 6 terms. They are not all alike. These 2 are alike. These 2 are alike. And these 2 are alike. So we may only put together or combine the likes. So let's start here. 4x minus 2x is going to be 2x. And then we'll bring down plus 6y plus y plus 12 minus 9. It's like order of operations. Okay, now looking from left to right, we would want to next add these 2, but we can't. X is not like y, so they have different letters. They're not like, so those cannot join forces. Let's go to the second and third terms. Can they join forces? Yes, they can. 6y plus 1y is 7y. Bring down the rest. Now working from left to right, these 2 cannot go together. These 2 cannot go together. This has a y and this doesn't. Can these 2 go together? Sure, plain old numbers. 12 minus 9, 3. Bring down the rest. And that problem is considered finished because we have put together and joined forces with everything that we could. We are left with 3 terms in our final answer, and sometimes that happens. That's okay. All right, combining like terms, some language, terms, coefficients, like terms. Thanks for watching, and happy trails to you.